Alright, we have the problem here from function, and we are to find the domain and the range of this function. So function is f of x equals to ln of twice x plus 7 divided by 7 minus x. So our first target is to find the values of x, that is domain. So our solution, first we want to find the values of x domain. Okay, so we have a problem, and here our function is ln of some terms in x. So now our input is, so f of x equals to ln of twice x plus 7 divided by 7 minus x. So what is this? This is just input, right? So input of ln function, input of ln function. So we know that ln function is defined only when the input is positive number, right? So if I take an example here, that f of x is ln of x, then x has to be greater than 0, right? Then this function is defined, otherwise not, right? So let me erase this. That's why our input, that is twice x plus 7 divided by 7 minus x, this has to be greater than 0, right? Now since this has to be greater than 0 and this is a fraction, right? So this is a fraction. Since it's a fraction, then we have 7 minus x, that is our denominator, and this denominator is not equal to 0. That gives x cannot be equal to what, 7, right? Now we have another observation, that is it's greater than 0, that is this function is not equal to 0. Then we have our second observation is twice x plus 7 divided by 7 minus x is not equal to 0 also. So if a fraction is not equal to 0, then we can say the numerator is not equal to 0, and that's why we can say this x, after solving this, we have x not equal to negative 7 by 2. But we are not done here, right? Because on the real line, this is 0, this is 7, and this is negative 7 by 2. Now we cannot take this 7 and negative 7 by 2 as the values of x, right? So this has to be neglected. Now since this is positive, so we have possibilities here. So okay, I want to take this and this over there. So x is not equal to 7 and x is not equal to negative 7 by 2. Now I can erase this here, right? Okay, so if a fraction is a positive number, then we have possibilities, that is twice x plus 7 is greater than 0, and this 7 minus x also greater than or equal to 0. So if both the numerator and the denominator is uh, positive, then this fraction will be positive, right? So after solving this one, we have x greater than negative 7 by 2, right? I think you agree with this. So, and this 7 minus x greater than 0 gives us 7 is greater than x and x is less than 7, right? Okay, and also, okay, this is my third observation, and this can be positive when both the numerator and the denominator is negative, right? So if twice x plus 7 is negative and 7 minus x is negative, then this will be positive. So twice x is less than minus 7 and x is less than minus 7 by 2, and then this 7 less than x and x greater than 7, right? Okay, so this is our negative 7 by 2 and this is our just 7, and we know that these two values will be neglected. So x is greater than minus 7 by 2. So greater than minus 7 by 2, that means this also this part will be included, and x is less than 7. So x is less than 7, that means only this part, right? And also this. So this and this, that means 3. So our observation 3 implies that x is x lies in negative 7 by 2 to 7, and we cannot take these two endpoints, right? Okay, now from this x is less than negative 7 by 2 and x is greater than 7. Actually these two inequalities uh, don't don't give me any any values of x. That is, after plotting these inequalities, so minus 7 by 2 and this is 7, so x is less than negative 7 by 2. So x is less than negative 7 by 2, that means uh, these points, and x is greater than 7 by 2, so x is greater than 7 by 2 is this point, and we know that negative 7 by 2 and 7 by 2 will be neglected. So on this real number we don't have any uh, common common parts, right? That's why from our observation 4 we don't have any x values here. So our domain will be this part. Okay, so domain will be this. I think you have understood. Now let me erase this first and then I will move to the next part, that is uh, to find the range of this function. Okay, so our domain is this. Domain is negative 7 by 2 to 7, and this is our domain. Now come to the next part, that is range. We want to find the range. So range is the values of f of x, right? So values of f of x, but we have our domain is negative 7 by 2 to 7. So if I take this, or if I set this twice x plus 7 by 7 minus x, that is, if I set this input equals to t, then our function is f will be ln of t, right? Where t is equals to twice x plus 7 divided by 7 minus x. So f will be uh, defined for t greater than 0, and we have our domain here. So simply ln of t looks like, so this is the graph of ln of t, right? That is, ln of t is from negative infinity to positive infinity, right? That is the y direction. So range is negative infinite to positive infinite, but I will show you how this uh, range we figure out. Okay, twice x plus 7 by 7 minus x equals to t, then s becomes ln of t. Now when x x approaches to negative 7 by 2, x is not equals to negative 7 by 2, right? Because here negative 7 by 2 is neglected. So if x moves to negative 7 by 2, then t moves to, right? T moves to. So this is 0 and negative 7 by 2. Okay, so t moves to what? Now our limit x tends to negative 7 by 2, then twice x plus 7 by 7 minus x. So here this uh, if I put this negative 7 by 2 instead of this x, so we have 0 here, right? So t moves to 0 when x moves to negative 7 by 2, then t moves to 0, and if t moves to 0, then f moves to what? F moves to negative infinite, right? Negative infinite, because this ln function looks like this. So when the input moves to 0, the function or the ln function that goes to negative infinite, right? And similarly, if I take this 7, that is, if x moves to 7, x moves to 7, okay. So when x moves to 7, then t moves to what? If x moves to 7, then t moves to, we will find this from this equation. So limit x tends to 7, and then 7 twice x by, sorry, twice x plus 7 by 7 minus x, that gives you, so this will be what? Positive infinite, right? So positive infinite, then t moves to infinite, and if t moves to infinite, then f moves to positive infinite. That means if you uh, x if your x moves to negative 7 by 2, then f moves to negative infinite, and if x goes to 7, then your function f, that is ln of this part, so f moves to positive infinite. And we know that the range of any function is the values of f of x. So our range will be negative infinite to positive infinite. Okay, I think we are done. So range range of f is negative infinite to positive infinite, and you can see this is real number, right? So our domain is negative 7 by 2 to 7, and range is real number. All right, so we are done. Thank you.